students, today we will see how to solve type 3 numerical. Here the fuel given is a gaseous fuel, excess air is given, and we are supposed to find out what is the minimum weight of air required for the combustion of the gas, which is to be given in meter cube. And if excess air is supplied, then what would be the volumetric composition of the flue gas? This numerical is similar to what we have done in type 1, only difference is here the volumetric composition is given. Now in this numerical we are given hydrogen, carbon monoxide, methane, ethylene, nitrogen and moisture as the component of the fuel. So our first assumption comes out is written as let the basis of calculation be 100 kilomoles of gaseous fuel. So here we are taking 100 kilomoles of gaseous fuel instead of 100 kg of the fuel which we used to take in type 1 and type 2. So we have our first table which comprises of 4 columns. In the first column we are taking the constituents of the fuel. In the second column we are taking percentage and kilomoles. Since we are considering it 100 kilomoles of the gaseous fuel, so there is no need for further conversion and the percentage is taken as it is. Third column is used for oxygen calculation and the last column is used for the reaction. So we have hydrogen which is 44 kilomoles, which was 44% and we have converted it directly to kilomoles, so it is 44. We know that hydrogen reacts with half oxygen giving H2O. So the oxygen requirement over here is 44 multiplied by half, that is 22, and water which is produced, that is 44 kilomoles. Carbon monoxide, since it is 6%, that is 6 kilomoles. Carbon monoxide plus half oxygen gives us carbon dioxide. So again oxygen requirement over here is 6 into half, that is 3, and the combustion product which is formed, that is CO2, which we are getting 6 kilomoles. CH4, that is methane, kilomoles is 36. CH4 plus 2O2 gives CO2 plus twice H2O. So oxygen requirement over here is 36 into 2, that is 72 kilomoles. Carbon dioxide produced is 36 and water produced is 36 into 2 comes out to be 72. Next is ethylene, that is C2H4. Percentage given is 4, that is 4 kilomoles. C2H4 reacting with 3 oxygen giving 2 CO2 plus twice H2O. So oxygen required is 4 into 3, that is 12, and carbon dioxide form is twice, that is 2 into 4, that is 8. Water again 2, so you are having 2 into 4, that is 8 kilomoles. One thing makes the calculation easier. If you look at the coefficient of oxygen, carbon dioxide and water to calculate oxygen requirement, carbon dioxide formed and water formed respectively. So there you have to just multiply the coefficient with the kilomoles of the fuel constituent which is given. N2 6.5 kilomoles, you don't have any oxygen requirement but you have nitrogen in the reaction product. So N2 is 6.5. Similarly moisture 3.5. You don't have any oxygen requirement for moisture but it is seen in the reaction product. So on summation you get 109 kilomoles of oxygen per 100 kilomoles of fuel. So from minimum oxygen we can calculate minimum air using our same formula, a same relation. We know that in 100 kilomoles air you have 21 kilomoles of oxygen. So if we have 109 kilomoles of oxygen, what would be the amount of air? So this is 109 multiplied by 100 upon 21, which comes out to be 519.05 kilomoles of air per 100 kilomoles of fuel. Now in this numerical you have one important aspect where you are asked to find out the weight of air required for combustion of the gas. So here what we are supposed to find out is, we are supposed to find out the weight of the air required for combustion of 1000 meter cube of the fuel. This is the requirement for this type of for this particular numerical. So for finding out weight of air, what we do is we multiply the kilomoles of air by the average molecular weight of air, that is 28.95. The weight of air required for combustion of 1000 meter cube of this fuel is calculated by multiplying kilomoles of air with average molecular weight of the air, that is 28.95, upon 100. This is the kilomoles of fuel which we have taken, multiplied by 22.4, since we want to convert this fuel into meter cube, and we multiply it by 1000 because we are required to find out weight of the air for 1000 meter cube of this fuel. The answer comes out to be 6708.26 kg air per 1000 meter cube of the gaseous fuel at NTP. So this is our first answer which we are reporting. Now the second part says that 50% excess air is supplied. So the actual air supplied is 100 plus 50 upon 100 into 519.05. This is the minimum air which is required. So the air supplied, it comes out to be 778.57 kilomoles air per 100 kilomoles of the fuel. Then for the calculation of the, or for finding out the flue gas, we are supposed to find out the nitrogen and the excess oxygen, just like we do it in type 1 numerical. So nitrogen total is equals to nitrogen from fuel plus nitrogen from air. So nitrogen from fuel is 6.5, which we have taken from our table 1, plus the nitrogen from air is calculated from the air supplied, that is 778.575 into 79 upon 100. The total nitrogen comes out to be 621.57 kilomoles of nitrogen, which we put in our second table. Similarly, oxygen is calculated since we are supplying excess air. So excess oxygen is air supplied minus minimum air into 21 upon 100. So this, on doing the calculation, it comes out to be 54.50 kilomoles of oxygen. This we take in, this again we put it into our second table. Now there is a difference in type 1 and in type 3, that here you have many places where water is formed and where carbon dioxide is formed. Now first let us consider the carbon dioxide. So carbon dioxide, over here we are having carbon dioxide formed at one place where you are having combustion of CO, from combustion of CH4, from combustion of C2H4. So we are adding up all this carbon dioxide. So here we have 36 plus 36 plus 2, that is 50, and we put the total amount of carbon dioxide formed in table 1 into table 2. Similarly, we also calculate the water which is formed. Here it is 44 at one place, 72, 8 and 3.5. So all this taken together, summation of the waters formed at table 1, that is 44 plus 72 plus 8 plus 3.5. We take the summation of water and put it in our table 2. So it comes out to be 127.5. So summation of this kilomole, it comes out to be 853.57, and then we find out the individual percentage of the constituent. So carbon dioxide, it comes out as 5.86, oxygen as nitrogen as 72.82, oxygen as 6.39, and water as 14.94. So this is how we solve our type 3 numerical.